Good evening students. In today's class we are learning about screw pitch gauge and the gauges which are used in the workshop for general purpose. First of all we will see about the screw pitch gauge. What is a screw pitch gauge? It is a gauge to determine or to find the pitch of thread. When a job is there having a threads, the threads are unknown. The diameter of the threads easily can be checked with the measuring instruments, but the pitch of the thread, that is the distance between the threads, is not able to find easily, and for that purpose screw pitch gauges are used. These screw pitch gauges having a number of blades which are each blade has got a different sizes of threads cut on that, and the pitch of the thread also written on that. So by selecting the proper blade which is suitable to the threads, and by that easily we can determine the pitch of the thread. The purpose: a screw pitch gauge is used to determine the pitch of a thread. It is simple. It is also used to compare the profile of thread. So not only finding the pitch of the thread, also the shape of the thread, profile of the thread or shape of the thread, comparing the shape of the thread of the job to the screw pitch gauge, so that whether the thread's shape is perfect or any correction is required. So this also can be checked. Constructional features. Pitch gauges are available with a number of blades assembled as a set. Each blade is meant for checking a particular standard thread pitch. The blades are made of thin spring steel sheets and are hardened. So the screw pitch gauge, it is a set of a gauge having a number of thin plates or thin blades. So each blade has got different threads cut on that, and the size also written on that. These are hardened and tempered, and material is used for this is spring steel. Since it is a very thin blade, so spring steel is the best material for manufacturing this gauge. These are hardened and tempered so that there should not be any wear and tear. Some screw pitch gauge sets will have blades provided for checking British standard threads and at one end, and the metric standard at the other end. So some of the gauge having two ends gauges are available. So one end is meant for metric threads, other end for British standard, that is BSW, BSF threads. So like this gauge also available, or else a set completely used for metric gauges only, metric threads only, and another set which is used only for British thread. So such type of gauges also available. The thread profile on each blade is cut for about 25 to 30 mm. The pitch of the blade is stamped on each blade. The standard and range of the pitches are marked on the case. So each blade length is about 25 to 30 mm, and in that 25 to 30 mm, slightly more than that, 25 to 30 mm is the pitch cut on each blade for measuring easily and finding the or determining the thread of the job easily. And this pitch of the thread is stamped on the blade. So that means it is punched on the each blade. What is the size of the pitch? What is the size of the pitch? And this is the blade. Each blade, the standard range and pitches are marked on the case. For obtaining accurate results while using the screw pitch gauge, the full length of the blade should be placed on the thread. So this is a very important point while checking the pitch of the job by screw pitch gauge. We have to keep the blade the full thread of the blade should keep on the job or match with the job, and by that we can find or we can determine the thread easily. So this is a very important, but not just a few teeth are matching with the job and finding. So that may not be correct, because the pitch may vary, and for that purpose the full length of the blade, the full thread length of the blade, the teeth fully contacting the job, and by that we can find the external and internal threads of the job. So next lesson is simple and standard workshop gauges. In the workshop daily we are using many types of gauges like radius gauges, feeler gauges, and some more gauges are there. So all these gauges are used for different purposes. So each gauge has got its own application. So let us see one by one these type of gauges. Radius and fillet gauges. Components are machined to have curved formation on the edges or at the junction of two steps. Accordingly, they are called radius and fillets. The size of the radius and radius is normally the size of the radius and radius is normally provided on a drawing. The gauges used to check the radius formed on the edges of diameters are fillet, and the gauges used to check the fillet are called fillet gauges. So here in the job there are many curvature made on the surface. So each curvature will be checked with gauges, and these gauges are called either fillet gauges or radius gauges. If a radius is made at the corner of the gauge is used to check the radius formed on the edges of a diameter are fillet. If a radius is made at the corner of the job, such a radius is measured with the fillet gauges, and if a radius is made in the middle of the job, such a radius is measured with the radius gauges. They are made of hardened sheet metal, each to a precise radius. They are used to check the radii by comparing the radius on a part with the radius of the gauges. So the material used for manufacturing this radius gauge is a sheet metal, hardened and tempered sheet metal is used. Good quality steel is used so that there should not be any wear and tear, and not only that, it should not get rust also, and for that purpose such material is used. And these gauges are comparing the radius of the job, so that the radius of the job is correct while comparing with the gauges, and easily we can find out if any correction is required, or if the radius is big or small, easily we can find out. Figure in the textbook, the figure is given. It is the application of radius gauge to check the radius formed externally, and the second figure is there, the application of fillet gauge to check the fillet form on a turned component. The other typical applications are, so in the sketch, in the textbook, the sketch is given. If a corner radius is made, a curvature is made on the job, such a radius is measured with a fillet gauge. Such radius is checked with the fillet gauge, and radius is made in the middle of the job, such radius is called radius gauge. Then the other typical applications are given here. So the applications of the or use of the gauges are given. Checking the corner radius of part being filed to shape, and checking a radius formed by a milling cutter. So any corner of the job, if any radius is there, external radius is there, such radius is measured with or checked with the radius gauge, or maybe internal radius or external radius, both can be checked. So normally in a radius gauge, one end is provided for checking external radius, the other end the blades are provided for checking the internal radius. The radius and fillet gauges are available in sets of several blades which fold into a holder when not in use. So a gauge set is available. So one end is checking external radius, and one end is the blades are provided for internal radius. So when it is not in use, these blades can be folded, and the set can be reduced to small size. Some sets have provisions to check the radius and fillet on each blade, and some sets have separate sets of blades to check the radius and fillet. So some sets have only external radius can be checked, and some sets have got internal radius can be checked. So such gauge sets are also available. Each blade can be swung out of a holder separately and has size engraved on it. So each blade has got its own size. The size of the radius is written on that or stamped on that. Fillet gauges are available in sets to check the radii and the fillet form. So fillet gauges are used to check the radii and the fillet form. The shape of the radius is also can be checked with that. So these are available like sets 1 mm to 7 mm, steps of 0.5 mm. From each blade, the steps is increasing with the 0.5 mm, 1 mm, 1.5 mm, 2 mm, 2.5 mm. So that way it is increasing. Second set is 7.5 to 15 mm. So and each step is each gauge step is 0.5 mm. So this also 7.5 to 8 mm, 8.5, 9, 9.5, so up to 15 mm. Then above 15 mm, that is 15.5 to 25 mm gauge also available in a set with a step of 0.5 mm. Individual gauges are also available. They usually have internal and external radii on each gauge and are made in size from 1 to 100 mm in steps of 1 mm. So other than set, so individual gauges are also available. Individual gauges means only for the particular one size. So only single blade is available. So in this, for these blades are available for checking internal radius or external radius. So both can be checked. The both radius can be checked with a different individual gauges. And before using the radius gauge, check that it is clean and undamaged. So some precautions we have to take before using the gauges. So what is the one precaution is, first of all we have to clean the gauge nicely. We have to clean, and second thing is see that the gauge is whether it is damaged or no, that you have to see. If the damaged gauges are there, such gauges should not be used. Remove birds from the workpiece. And another point is there, so before using the gauge we have to clean the job, not only cleaning, deburring the job. So if any burr is there, over the burr only we should not check the radius. So before that we have to deburr the burr, or remove the burr, and after that the gauge will be used. Select the leaf of the gauge from the set corresponding to the radius to be checked. So in a set, when you are using a set, suppose the radius is the job radius is for example 10 mm radius you are making, so or we are filing. So from the radius gauge set, select 10 mm R10 or 10 radius blade. We have to pull it out, and that blade you have to check for checking the radius. Then here textbook figure is there that shows the radius of the fillet and that of the external radius and smaller than the gauge. So if the radius is smaller and the gauge is bigger, then you have to go for a particular gauge by selecting whichever the blade is suitable for the checking the radius. Such blade you have to select. Try a smaller gauge to determine the radius dimension. File or machine the workpiece if it has to be of the radius of the gauge. So if the radius is smaller, then we have to we have to make bigger radius either by maybe filing or by machining, and make it suitable to the equal to the gauge blade. Figure 11 shows that the radius of the fillet and that of the external radius are larger than the gauge. So here a figure is there. The radius is bigger but the gauge is smaller. So in that case, if possible, we have to do the correction, or if it is not possible, we have to change the job, or we have to change the material, and we have to prepare a new one. Try a larger gauge if you need to find the radius dimension. Figure 12 shows the workpiece having the same radius as that of the gauge that is being used for checking. So here in the figure, the correct size gauge is the correct size gauge which is used for selecting the radius, and the radius and the gauge is perfectly, the radius of the gauge and the radius of the job is perfectly matching each other. The next one is feeler gauge and uses. Now what is feeler gauge? If there is a gap between the job, maybe fitting the assembly part, when two parts are assembled together, and in the assembly when between the parts if there is a gap, this gap can be measured with a gauge, and the name of that gauge is called feeler gauge. Feeler gauge is available in a set having a number of blades with different thicknesses. Each blade has its own thickness, and this thickness is stamped on that each blade. By inserting this blade, we can able to check the gap between the meeting parts. If any assembly is there, so if any gap is there, so such gap can be measured or checked with suitable blade from selecting from the feeler gauge by insertion. So this is the main use of the feeler gauge. Features: a feeler gauge consists of a number of hardened and tempered steel blades of various thicknesses mounted in a steel case. In a steel case, in a set, number of blades are there. These blades are made out of a spring steel, hardened and tempered, as I told you previous gauge, for wear and tear. To protect the gauge from wear and tear, it is hardened and tempered. And second thing is, these are mounted in a set, and each blade has got different thickness, and this thickness is stamped on each blade. The thickness of individual leaves is marked on it. BIS set. The Indian standard establishes 4 sets of feeler gauges, number 1, 2, 3 and 4, which differ by the number of blades in each and by the range of thickness, minimum 0.03 mm to 1 mm in steps of 0.01 mm. So BIS, Bureau of Indian Standard, and Bureau of Indian established feeler gauge set, and these are available in 4 numbers, total 4 numbers, number 1, 2, 3, 4. And these gauges are available. The minimum, the blade thickness is 0.03 mm and the maximum is 1 mm and the step is 0.01 mm. That means the minimum blade is 0.03 mm thick, the next size is 0.04, next one is 0.05. So like that 0.01 steps. So total maximum 1 mm up to 1 mm the thickness of sheet is available, the thickness of blade is available. The length of the blade is usually 100 mm and each set, each number of blades are there and each blade length is approximately 100 mm. Example, set number 4 of Indian standard consists 13 blades of different thicknesses, 0.03, 0.04, 0.05, so like that 0.5 mm. The size of the feeler gauge is in a set are carefully chosen in order that a maximum number of dimensions can be formed by building up from a minimum number of leaves. So one important point is given. Suppose we want to build up a certain size. So with the minimum number of blades, we have to build up the size, not choosing more number of blades and building up the size. Instead of that, with the minimum number, say for example, if 0.5 mm is required, if 0.5 blade is there, it is okay. If not 0.5 blade, either 2.2 is there or 0.3 is there, with that we can build up with the 2 blades. Or else we can go for 0.1 like 5 blades, 0.1, but this is wrong. Selecting 0.1 blades of 5 numbers and building up the size is wrong. Instead of that, either 0.5 blade is available or else minimum one 0.2 and 0.3, so or 0.4 and 0.1, so like that also it is possible. So this is the meaning of the sentence. The size of the feeler gauge set are carefully chosen in order that a maximum number of dimensions can be formed by building up from a minimum number of leaves. The dimension being tested is judged to be equal to the thickness of the leaves used. When a slight pull is felt while withdrawing them, accuracy in when a slight pull is felt while withdrawing them. So while inserting this blade, the sense of feel is very important. So when after insertion, when you taken out the blade from the assembly, just a slight pull is required. Just a slight pull. It should not be loose or should not be tight. A slight pull is required. So for such blade we have to select for checking the gap. So blade should not be loose in the gap or should not be too tight in the gap. Just a slight pull is required while insertion and taken out while taking out. Accuracy in using these gauges requires a good sense of feel. So it depends of the workmanship. It depends of the technician who is using this. Just he should have a good sense of feel. Means selection of the blade depend upon the sense of feel. How he feels that you should not feel the blade in the gaps too loose or too tight. So a good sense of feel is important. Feeler gauges are used. The use of the feeler gauges to check the gap between the mating parts. In assembly, anywhere in the assembly, if there is a gap between the mating parts, when the gap between the two parts, this gap can be measured with the feeler gauge because no other instrument is possible to insert in that. So for that, feeler gauge is used. The second point, to check that to check and set the spark plug gaps. So in the automobile industry, spark plugs are there in the vehicles. So the gap between the spark plug is very important for sparking. If the gap is more or less, it will not spark, and for maintaining that spark plug gap, the feeler gauge is used. Third one, to set the clearance between the fixture, setting block and the cutter tool for machining the job. So while machining the job on the machine bed, certain gap should be maintained between the cutter and the job, and this gap can be maintained with the help of feeler gauge. Easily we can maintain the gap between the job and the cutter, and that gap can be with the feeler gauge. To check and measure the bearing clearance and for many other purposes where a specified clearance must be maintained. Bearing clearance, when the two surfaces are contact each other, certain gap should be maintained. When one surface is sliding over the other surface, then certain gap should be maintained. This gap can be maintained exactly or accurately with the feeler gauge. And similarly, this feeler gauge is used for maintaining the gap between the jobs in many other users. In many other places, the gap between the two meeting parts should be maintained. Certain gap should be maintained, and this gap can be maintained accurately with the feeler gauge. Next, drill gauges. A drill gauge is a rectangle or a square shaped metal piece containing a number of different diameter holes. The size of the hole is stamped against each hole. So, drill gauges, a metal plate having a number of drill holes, and each hole has got its own size, and this size is written or stamped on the just near to the hole. And this is called drill gauge. So, what is the purpose of this gauge? In the number drill and letter drill series, the diameter of the drill is gauged with the help of the respective drill gauge. So, purpose of this drill gauge, if the drill size is of odd size, not even number, odd size. So, after the decimal, some odd numbers are there. So, such drill are difficult to measure the diameter. So, for that purpose, a steel plate having a number of holes with the different drill holes, and either the size is written, or the number is written, or the letter is written. So, by inserting the drill bit in that, and the shank of the drill bit inserted in that, and checking that whichever hole is suitable for the drill bit diameter, and such that is the size of the drill. If the drill is unknown, the size of the drill is unknown, so easily we can measure the diameter of the drill by inserting the drill in that plate, whichever hole suitable for the correct slide in the drill bit, in which hole the drill bit correctly sliding, and that is the size of the drill bit. So, either this written number or letter. So, this is called drill gauges. Drill point grinding gauge. Drill point grinding gauge having an angle under 18 degree. In the 18 degree angle outside 0.5 graduations are marked to check the length of the cutting edge. In inches version, this tool is calibrated with 1/32 parts of an inch. So, drill grinding gauge. Normally, the drill bit cutting angle of a drill bit under 18 degree. So, while grinding or while resharpening the drill bit, certain gauge is required for maintaining that under 18 degree angle, and for that purpose, a gauge is used for maintaining the drill point angle while grinding under 18 degree, and that gauge is called drill point grinding gauge. It consists of a sliding head mounted on a steel rule. The head may be positioned on the rule and clamped by a knurled nut. So, this is a long rule is there, a graduate rule is there. So, for this rule is used for checking the length of the lip. After grinding, the both lip of the drill bit should be equal, and this lip can be measured with the steel rule. And the arm is there, and that is used for checking the angle, that is under 18 degree angle. This gauge is used to check the correctness of the cutting angle under 18 degree of the twist drill after resharpening by hand. After resharpening by hand on bench grinder for checking the angle and also for checking the lip length, this gauge is used. Center gauge. A center gauge is made up of spring steel hardened and tempered and is used mainly for grinding and setting single point thread cutting tool. These gauges have graduation for checking the number of threads per inch. Some gauges have a table giving the double depth of various threads and also used to check the include angle 60 degree of ground lathe centers. So, center gauge. These center gauges are used to check the spring steel hardened and tempered and is used mainly for grinding and setting single point thread cutting tool. Grinding. So, while thread cutting on lathe machine, maybe for metric threads 60 degree angle is required, and for British threads 55 degree angle is required. For checking this 55 degree or 60 degree, some gauge is required, and that gauge is called center gauge. These gauges are used to check the single point cutting tool angle. Single point cutting tool angle. These gauges have graduations for checking the number of threads per inch. Some gauges have a table giving the double depth of various threads and also used to check the include angle 60 degree of ground lathe centers. For internal threading, the cutting tool is set to square with the help of center gauge and a steel rule. So for internal threading, the thread cutting tool must be perpendicular to the job bore, the bore of the job, and this is possible only by keeping the center gauge, and with the steel rule we can check the tool exactly perpendicular to the job bore. When cutting tapered threads, the center gauge is used to set the cutting tool square with the axis of the workpiece. So while cutting the external threads or tapered threads, external tapered threads, so this center gauge is used to check the to set the tool, not to check, it is to set the tool perpendicular to the job axis with the help of the gauge and with the steel rule. ACME thread gauge. An ACME thread gauge is used when grinding threads cutting tool and also for setting the tool square with the work. So ACME thread, the shape of ACME thread is there. These threads are not V-shaped threads. It is something like trapezoidal threads, and these threads for setting the tool certain gauge is required, and that gauge is called ACME thread. So ACME threads, the width of the each groove is different in size, and similarly the gauge is having a number of various grooves. So whichever suitable groove is there, with the help of that we can grind the tool, and also we can easily set the tool perpendicular to the job axis on the lathe. The notches on the edge of the gauge are for checking the correct width of point of the tool according to the number of threads per inch specified for ACME thread. It is made of spring steel and hardened. Similarly, a metric thread gauge is also available. So it is a simple plate having a number of notches, number of grooves of different width, and this is made out of spring steel material, hardened and tempered, and this is used for either metric or separate gauges available either for metric threads or for British threads. And these with the notches we can, according to the width of the thread, and we can grind the tool by matching the tool tip to the gauge, and also for setting the tool on the machine, on lathe machine, this gauge is more helpful. Next, standard wire gauge. It is used to measure the size of a wire and thickness of the sheet shown. So standard wire gauge, by the name itself we can understand that since wire word is there, it is used to measure the diameter of the wire and also the thickness of the sheet, because normally the sheet is available in a gauge number. It is not in a millimeter or inch size. No, it is gauge number. The thickness of the sheet is available, and this thickness of the sheet can be measured with standard wire gauge. The standard wire gauge is a circular metal disc with varying hole and slot size on its circumference. Each slot size corresponds to a gauge number which is written just below the hole. So each hole and the slot is provided, and that hole and the slot size is stamped just below that. The gauge number specifies the size of a round wire in terms of its diameter. If it is a wire, measuring the wire, the diameter of the wire with this gauge only, and that number is written on that the particular hole size just below the hole. That means the gauge number is there. If wire is entered in that, and whichever number is written in the just below that hole, and that is the gauge number of that wire. As the gauge number increases from 0 to 36, the dia size decreases. So when the gauge number increases, the dia of the wire is reduces. That means 0 is from 0 to 36 number, the dia size decreases. That means 0 is the biggest one and 36 is the smallest one. The thickness of a sheet metal and the diameter of wires conform to various gauging numbers, and the following table gives the decimal equivalent of the different gauge numbers for the diameter of wires and the thickness of the sheet. So after knowing that number, maybe the thickness of the sheet or the diameter of the wire, by matching with the wire gauge, then the chart is provided, and referring the chart, the number of the gauge number, say it is a 10 number. So from the chart, 10 number means what is the size of the equivalent size of the 10 number in millimeter. So by that we can know that what is the exact 10 number size means in millimeter. The conversion we can check from the gauge, and this is called a standard wire gauge. It is used mainly for checking the thickness of the sheet metal and also the diameter of the wire, and after matching with that, with the whichever is hole is suitable for the wire or the sheet metal, and then you have to go to the table and then you take the conversion from the gauge number to the nearest millimeter size. Okay, thank you students.